Hi everyone. So welcome to Design and Analysis web series. I have posted so many concepts related to design and analysis algorithm like recursive and non-recursive algorithm, greedy algorithm, dynamic and so on. So if you want to know more about this, kindly subscribe and follow. Hi everyone. Welcome back to DOS series. Today we are going to see master theorem to solve the mathematical analysis for recursive algorithm. So already we have another way, that is substitution method. So this is one of the second method where we can solve the recursive algorithm using the master theorem. So master theorem is derived with the formula such that if f of n belongs to big O of n to the power d, and here we have some of the constant value which should be greater than or equal to 0. So here we are seeing the previous method, substitution method, that is divided into forward substitution and backward substitution. This is the previous method we have seen to solve the recursive algorithm with the help of recurrence relation. So this is a master theorem second method which help us to solve the any recursive algorithm. We need to follow one particular format for the master theorem. Such kind of recurrence relation only could be solved using the master theorem. If the format, for example, T of n is equal to a n by b, so that should be defined with the help of the f of n function. So first we shall see what is master theorem. If f of n belongs to big O n to the power d, so where this d is greater than or equal to 0, so this is appear in the recurrence relation. So we will be forming one of the recurrence relation. So there we have the d greater than or equal to 0 we need to find out. So what we need to find out is a b to the power d. These two expression we need to find. For that we need to know the value of a, b and d. And they may fall in any one of the category, either less than, greater than or equal to. So if they fall in any one particular category, then directly we can fetch the time complexity of that particular recurrence relations. So here, for example, a greater than b to the power d, then directly we can say the time complexity is n to the power of log a base b. So this is the time complexity for that particular recurrence relation which belong to a program. Maybe a factorial recursive algorithm or something else, merge sort using recursive algorithm likewise. So here we can consider one example. A of n is equal to a, either you can have the value of a and b, so n by 2 plus 1. So here the particular recurrence relation should be in the format of this one. So a, capital A, n by b plus f of n, any function, n square, n to the power 4 likewise. So definitely for the master theorem the recurrence relation should be in this format. So a value can be assumed as 2, b can be assumed as 2, and f of n is nothing but any function, n squared or n to the power 4 or something else. So that particular value is considered as a d value. Okay, so f of n is any polynomial expression can be given in the recurrence relation, so that we can receive the value of a, b and d. Suppose the recurrence relation is not in the format of this a n by 2. For example, t of n is equal to t of n minus 1 plus 1. So here we don't have the value of a and b, or else maybe less than 1 or something else. It should be greater than or equal to 1, b. Then only the particular equation, recurrence relations can be solved. See, such kind of format which is not belong to the a, capital A, n by 2 plus f of n format, we cannot solve those recurrence relations for the master theorem. So only divide and conquer, merge sort. So likewise recurrence relation could be solved using the master theorem. So here we can see one another example to solve this master theorem. A of n is equal to 2a n by 2 plus 1. We can take the same example and solve a. What is a? 2. So a value is 2. What is the value of b? B value is equal to 2. And what is the value of d? There is no function at all. A constant value is appearing. Therefore d value is 0. So now we shall find the expression. Suppose instead of 1, if the value is appeared to be n or something else, so d value will be 1. Suppose n to the power 4, then the d value will be 4. Likewise, we need to find the value of d belong to the f of n function. So here we are having 1, therefore there is no value for d. We will substitute as 0. So now we need to find the expression a b to the power d. These two expressions will help us to find which category of time complexity. So 2 to the power of 0. 2 to the power of 0 is 1. So a value is 2, b to the power d is 1. So which category? 2 greater than 1. So a greater than b to the power of d. It falls on the third category. Therefore the time complexity will be big O n to the power log a base b. So big O n log, what is the value of a? 2. So 2, what is the value of b? 2. So log 2 base 2. So this is the time complexity for this particular recurrence relation. So likewise we can find any time complexity directly, easiest method in the master's theorem. No need to substitute and find the various equations like forward substitutions or backward substitution. Okay, this is the simplest way. Thank you.